All right, so in this video, we're going to be talking about imaginary numbers. So equations such as x squared plus 1 equals 0 have no real solution. So mathematicians define the imaginary numbers to represent their solutions. So you have an imaginary unit, I, and that is defined as I equals the square root of negative 1. So the reason they say that x squared plus 1 has no real solution is because when you're used to working with it here, you would solve this and you would say, okay, well, x squared equals negative 1. And then when you solve by taking the square root, you would say, okay, x equals the square root of negative 1. Well, you can't take the square root of negative numbers, so there is no answer. Well, now we're learning that there actually is an answer. You can say or state that the square root of negative 1 is I. This is an imaginary solution. So a pure imaginary number is written in the form bi, where b is the real number and I is the imaginary part. So all they're saying here is, let's say the solution were 3i. You would write it like this. 3 is the real, I is the imaginary. You would not say something like I3. So let's start by looking at a few examples. So we know how to take the square root of positive 9, but not negative 9. So here's what we need to do. We're going to split this apart so where we have the square root of negative 1 times the square root of positive 9. Because we don't know how to take the square root of negative 9, we only know how to take the square root of negative 1. So I need to think, okay, well, negative 9 divided by negative 1 gives me positive 9. So if I multiply these two radicals together, I get negative 9. So the square root of negative 1, as we just defined, is I. The square root of 9 is 3. So you wouldn't say I3 is the solution, because remember, standard form is the real number first. So here that's going to be 3i. If I came over here to number 2, same thing, square root of negative 1 times the square root of 196. Well, we know the square root of negative 1 is I. We know the square root of 196 is 14. So our solution is going to be 14i. So let's come down and try one like number 4. We have the square root of negative 1 times the square root of 80. And now we're going to simplify here. So the square root of negative 1 is I. The square root of 80, we need to break this down so we have the largest perfect square. So the largest perfect square that can go into 80 is 16. And 80 divided by 16 gives us 5. So here we have I times 4 times the square root of 5. So we want the real to go in front of the imaginary. So my solution here is going to be 4i root 5. So we'll go over here and do 6. The reason being is because with 32, your largest perfect square is 16 again. So I want you to see something different. So here we have the square root of negative 1 times the square root of 192. So the square root of negative 1 is I. 192. If I break this down, that's going to be 64 and 3. Now, if you're watching this video and you want to know how I'm coming up with that, if you go to your calculator, you can click right here on the y equals, and then you can type in the number that you're looking to simplify. So here, that was 192, and I'll say 192 divided by x. Now when I hit second graph, this gives me a table. And what I'm doing is I'm just scrolling down and I'm looking for the largest perfect square. So I find that here at 3 and 64. So that's where these numbers are coming from. So I have I times 8 times the square root of 3. So my solution here is 8i root 3. So that's how you simplify. Now, when you're solving an equation, it's not going to be any different than what you're accustomed to. So here we know we have to isolate the x squared. So we'll do that by subtracting 81 from both sides. Now I have x squared equals negative 81, and we'll solve by taking the square root. So normally here you would say no solution. Well, now we know how to take the square root of negative numbers. So x is going to equal the square root of negative 1 times the square root of 81. So the square root of negative 1 is I. The square root of 81 is plus or minus 9. Now here, the plus or minus comes in because we have an equation. Up here, we didn't have to worry about it. We were only concerned with the principal root because this was an expression. But when you have an equation, you have to take into account both. So this is going to be plus or minus 9. So my solution here is going to be plus or minus 9i. So this works with all four. I'll do number 9 with you. So I'll start by isolating the x squared. So I will subtract 15 from each side. Now I have 4x squared equals negative 24. I'll isolate my x squared. I'll solve by taking the square root. Now the square root of 6 cannot simplify, so here I have plus or minus I times the square root of 6. (11) and 12 aren't going to be any different. Just know that if the numbers are larger, you can use the calculator to help you find the largest perfect square. So I will do one like 12 because I haven't done a fraction yet. So let's start by adding 1 to both sides. So that gives me negative 2/3 x squared equals 18. So the way you move a fraction here is you multiply by the reciprocal. So that's going to be negative 3/2. So I'm left with x squared equals negative 27. Now I can solve by taking the square root. So x here is the square root of negative 1 times the square root of 27. We can go ahead and simplify the square root of 27. So here we have I times the square root of 9 square root of 3. So x here equals plus or minus 3i root 3. All right, moving on to powers of I. So here, sometimes this can get a little confusing. So we know what I to the 1 is, because we know that I represents the square root of negative 1, and we've notated that the square root of negative 1 is I. Now some of you may be thinking, Mr. Phillips, that was kind of pointless to state. Anything raised to the 1 power is itself. So this value didn't change. But I want you to see how we're developing this solution here, because that's going to work for the remaining 7. So I squared, well, this is going to be negative 1 times the square root of negative 1. So anytime you multiply a radical times a radical, the radical goes away. So here this solution is just negative 1. You could think about it like this. You could change a radical to a rational exponent. So this would be negative 1 to the 1/2. That's how you would write it, as a rational exponent, times negative 1 to the 1/2. And now you can use your property of exponents. When you're multiplying and your bases are the same, the base remains constant, and then you add the exponents. Well, 1/2 plus 1/2 is 1, and like we just said right here, anything to the 1 is itself. So that's how we got negative 1. Let's try I to the 3rd. So we have the square root of negative 1, square root of negative 1, square root of negative 1. Now we can go through and simplify here. We already know what this is. We just worked it out in the previous problem. This is negative 1. We also know what the square root of negative 1 is. We've already worked that out. So here we have negative 1 times I. So this solution is negative I. We'll do the same thing with I to the fourth. Now here, you don't have to go through and multiply all throughout. We've already done this. Here, the square root of negative 1 times the square root of negative 1 is negative 1. It'll be the same way here. So negative 1 times negative 1 is positive 1. Now that's a big deal because positive 1 is a much easier number to work with than any of the prior three. So we're going to treat it that way when we do the remaining four problems. Here, I don't want to write out I to the fifth. I don't want to say the square root of negative 1 5 times, especially when I know I to the fourth is 1. So let's think about this. Here's I to the fourth. That's easy to work with because we know it's 1. So now I need to say, okay, well, how many i's do I need to get to I to the fifth? Well, that's just 1 because I to the fourth times I is I to the fifth. Well, we know I to the fourth here is going to be 1. So 1 times I is I. So as we progress here, this would be I to the fourth times, and I say, okay, how many i's still remain? That'd be I squared. Well, we already know what I squared is. We found it over here. It's negative 1. If I did I to the seventh, that would be I to the fourth times I third, where we know what I to the third is. It's negative I. Here, this would be I to the fourth squared. Now, you could say I to the fourth times I to the fourth, but this is just another way of rewriting it. So this is just 1 squared, which is 1. Now, this is what we're going to use, this format here. I to the fourth raised to a certain power, especially when we have much larger exponents. So on 13, if I have I to the fourth, I need to think, okay, how many times can 4 go into 15? Well, 4 will go into 15 3 times with 2 left over. Excuse me, with 3 left over. So we know that I to the fourth is 1. 1 cubed is 1. So this is really just 1 times I to the third. And we know what I to the third is. It's negative I. Same thing with 14. I could say I to the fourth. All right. So how many times would 4 go into 62? It would go in 15 times with 2 left over. So here, I squared is negative 1. So what we'll do is we'll simplify the expressions knowing what we know now about the values of I. So I'm going to go straight down and do all of these on the left. So 4i times 7i. You'll treat this like you normally would any other expression. So you would multiply like terms. So 4 times 7 is 28. I times I is I squared. We know the value of I squared. I squared is negative 1. So this solution is negative 28. So here on 17, if I have 2i to the third, this is 2i times 2i times 2i times 5i. Now, you could just cube, say 2 cubed is 8, and then I cubed is I cubed. You could have done that, but I'm just expanding so you see how all of this plays out. So 2 times 2 times 2 is 8, times 5 is 40. I times I times I times I is I to the fourth. We know the value of I to the fourth. It's positive 1, so the solution here is 40. Let me do 18 because you haven't seen one with a square root. So here this would be I square root 3 times I square root 3, and then we'll rewrite the second term in a different color. So this will be minus 8i times negative 8i. So here, I times I is I squared. The square root of 3 times the square root of 3 is positive 3. Negative 8 times negative 8 is positive 64. I times I is I squared. So now we have 64 times 3, which is 192. I squared times I squared is I to the fourth. Well, I to the fourth is positive 1. So this solution here is going to be 192. Now, for 19 and 20, you have a bit of a conundrum because you're multiplying these two radicals. So the default is to say, oh, well, negative 18 times negative 10 is going to be positive 180. So let's go ahead and say the square root of positive 180. Okay, well, this is wrong because all the radical rules that you know of only apply when you have a positive radical. So you do not have positive numbers underneath the radical here. So we cannot multiply. We can only multiply when the radicals are positive. So what we're going to do is we're going to take the I out first. So now I can multiply and say this is I squared times the square root of 180. Now we can simplify the square root of 180. I have I squared times the square root of 36 times the square root of 5. So here I have I squared times 6 times the square root of 5. So my solution, remember this is an expression, so there's no need for the plus or minus. It's just going to be 6i squared times the square root of 5. And we know what I squared is. I squared is negative 1. So here, this would be 6 times negative 1 times the square root of 5. So this solution is negative 6 root 5. Same process on 20. We'll take the I out first. So I have I times the square root of 24, I square root 3, I square root 2. So I times I is I to the third. 24 times 3 times 2 is going to be 144. So I to the third here is going to be negative I. The square root of 144 is 12. So this solution is negative 12. Let me rewrite that so it's neater. Negative 12I. All right, that's all for this video. That is your introduction to imaginary numbers.